Hello and welcome to the video. Today we're going to be talking about remotely deploying code to an Arduino, specifically in the context of robotics applications. So let's start by defining the problem. If you are starting off with Arduino, the default tool you're probably going to use is the Arduino IDE. So let's fire that up. And we're just gonna do a new sketch and throw some basic code in here. So the first thing we're gonna do, we're just gonna get something in that's gonna make the LED on the Arduino blink. So we'll do pin mode in setup 13, output, and then down here in the loop we're going to do digital write 13 high, delay 1000, which should be 1 second, and then digital write 13 low, and delay will again be 1000. Okay. So this code should make the LED on the robot blink, or on the Arduino blink. So let's go ahead and save the sketch, and I am going to just drop it under, doesn't matter where you put it, I'm putting it under Python projects and lessons, since that's where I put all of these, and Arduino deployments. And then later on, it's going to be important to have the INO file and the folder named the same thing. So we're going to do firmware, because this is the firmware for our robot, and then we'll call it firmware. All right, so we have our firmware file. We have our, blinking code here. Well, how do we upload it? Well, using the Arduino IDE, we need to physically connect the robot. So I'm going to come over here. I've got a USB cable from my computer, and I'm just going to disconnect the Arduino, this little board down here, if you can see that, from the robot. And then I'm going to plug in the cable from my computer. Okay. And we'll go ahead and choose Arduino Nano and upload. Expected before the high token, because I left out a semicolon. All right. So we're going to do an upload, and it's done uploading. And at this point, we should have a gentle blinking in here. And you can kind of see in the video that is happening. We have a light blink underneath our Arduino. And this is great if you are working on something where you're comfortable just leaving the robot hooked up to your computer all the time. But if you're trying to iterate quickly, if you're, let's say this robot isn't on the computer, it's, rolling around your workspace, and you're trying to work on it because, that's what it does. It's a mobile robot. It's supposed to move. You probably want to be able to do this remotely, and the Arduino IDE is not a great way to do that. So let's talk about how we can. Let's talk about the best way to, or at least the way that I've found so far, to do these things without being hooked up to the robot. And for the setup, I've actually already set this up on the Raspberry Pi that's in the robot. So we're actually going to do setup on my computer here, and then I'll show you how it works remotely. So in order to run a successful remote install, we are going to set up the Arduino CLI. And I'm going to link an article in the description with the steps, so you do not have to type these in with me. You can just go down to the video description and follow along there if that is easier. But we're first going to run this and grab, let's see, what do we not like? Let's do one thing at a time. Let's do our install. So we're going to pipe that to sh. Let's just go ahead and do curl that to install.sh. And we'll chmod that to chmod plus x, and then go ahead and run it. Okay, we have successfully downloaded in our lessons folder, which is not where we want it. And then we need to move bin to /Arduino CLI to user local bin. No, and we need to do that with sudo. Okay. We then need to go ahead and do an update index. So that's going to be Arduino CLI core update-index. All right, and then it tells us that our package index has been updated. We also need to do an Arduino CLI config init, and that sets up our config. We'll need to modify our user so that we have access to interact with the tool. So sudo usermod ag.user. And then we should be in a good place to go ahead and start working with it. We do need one more thing. We need a library install. In this case, I need the PID library. So we're going to do Arduino CLI lib install PID. I'll need this later. We don't actually need this for the demo. All right, so let's talk about our basic workflow here. So at this point, all we need to do in order to successfully run these, first off, we can get rid of install and bin. So we now have a firmware folder, and inside of that firmware folder, we have okay, we've got that doubled up. We've got firmware/firmware. That should not be the case. Let's go ahead and fix that. Let's do firmware, and we're just going to do firmware back. Move firmware back to firmware. All right, little mistake there. So we now have a firmware folder with a firmware.ini file in it. So at this point, what we should be able to do is we should be able to run a compile. So that's going to be Arduino. And this is the section that you're going to run over and over again. This is the, what you probably want to wrap into a build.sh or something as part of your workflow. So you're going to do a Arduino-CLI compile, fqbn, --fqbn. And if that feels a little weird, if you're used to typing FQDN, fully qualified domain name, I believe this stands for fully qualified board name. We're going to do Arduino, AVR, Uno, and then our path to our sketch, which in this case is just firmware. And we can see that it did successfully compile. And then we need to do an upload. So we're going to do board, Arduino, CLI, upload-p. And in this case, I believe this is on TTY USB 0. But let's actually test that. Let's do ls USB. That is not what I wanted. Okay, I only have an ls, a TTY USB 0. So, and let's just make sure I'm going to unplug from the Arduino and run it again. And there's no more USB 0. Cool. Plugging back in. All right, it's back. I wanted to test that because I obviously don't want to go throw code at some device that is not our Arduino. I have actually messed up my keyboard before doing that. So, all right, so we've got Arduino CLI upload dev TTY USB 0, FQBN, Arduino, AVR, Uno, and then we're going to do / and firmware. Okay, and I missed something here. Command board not found. Because that is not the name of the command. And I need to do a double dash in front of FQBN. All right, I'm actually expecting an error here. I'm expecting 2 errors. Yep, programmer is not responding. So this is something, there are 2 reasons we could be running into this. Let me copy this. And we're just gonna close and relaunch the terminal. So we did make a user change earlier that probably hasn't been picked up. So this should still fail. And I'll show you why. But let's make sure it does. All right, so we're getting a programmer's not responding. So in this scenario, this is for the default Arduino board, the actual, the one sold by the original manufacturer. A lot of the Arduinos that you'll find out there are clones, which is fine, but they don't all use the latest bootloader. So in order to make my particular board work, I am having to throw in the old bootloader. So I'm going to do Arduino AVR Nano equals AT Mega 328 old. Let's see, what do we not like? I think I may need to, yeah, the nano part is kind of important too. Nano : CPU. All right, and that is actually a successful upload. But how can we tell? Because we, our blinky light is still blinking at effectively the same rate. Well, let's go ahead and hop into our firmware here. And we'll make the delay 500. We'll make the light blink a little faster. Okay, we just compiled and we're uploading. And what we should see now is that our blinking light is now blinking at 2 times per second instead of once per second. But we're still obviously hooked up to the computer, right? So we haven't achieved full success here yet. But here's what this approach allows us to do. Because we've boiled the upload down to 2 commands instead of sitting there in an IDE, I can now disconnect my robot. I can start up the robot by connecting the power. And you'll notice, again, nothing connected to the computer anymore. So now, if I want to shell into the bumper bot, which is what this little guy's called, it's going to take a second to show up on my local network. All right, I'm now shelled in. And I'm actually not going to upload the demo firmware we just put together. I'll upload the real firmware, but it'll be the same flow. So if I wanted to deploy something to this robot, I would simply commit it to Git. In this scenario, you could do this any number of ways. You could have a shell script or an Ansible script that push something over to your robot. In my scenario, I'm committing the scripts to Git, pulling them down to the robot, and then on the robot, I have a update Arduino script that I can just run. And it's going to go pull in my firmware and upload it to my Arduino. And that update Arduino script is just what we saw. It's a compile command pointed at, in my case, a robot control directory, and an upload command pointed at that same directory with the Nano fully qualified board name. And that's really it. So this process lets you effectively take your computer out of the loop or out of the direct connection loop. It lets you use whatever IDE you want to work on your Arduino board, and then you're able to script the deployment of your Arduino source code. And I think that makes your workflow a lot more flexible. So again, if you didn't catch all the commands, which is fine, I meandered a little bit, there will be an article in the video description that covers all of the setup commands for you to go and implement this on your own project. And with that, I'm going to say until the next video.